So we load tidymodels. Click run here. I wait until it's done. See, the chevron is not coming up. Takes a moment, I don't know. Usually it's a little faster. Oh, here we go. You can click ahead, but it's just safer. Load, reading the R file, janitor cleans up the data. I load the data. I make sure that my randomness is reproducible. And now comes the more substantial part. First, I split my data into training data and into testing data. And the splits are saved in this variable. Let's do it. And I create a recipe. We did that before, and the recipe is saved here in the variable recipe OLS. You can name it whatever you want. So recipes are usually built on the training data and then later applied to the testing data. And what the recipe expects is first the name of the function. It's called recipe. And then a formula that gives the recipe information. What is the outcome variable, the one we want to predict? And what are the variables we want to use? I list them here one by one. Sometimes you simply want to have all of them. Then you can just have a dot. That means use all of them. I list them. Okay, and then the last thing is, where are your data coming from? And instead of typing a training data set that I don't even have at this point, I use the function training and say, hey, use the split that I defined before. That should make sense now. If not, interrupt. You will struggle with the homework. These parameters can miss, so we can do it like this if we want to. And again, the information, which record goes to the training data, which record goes to the testing data, is saved in this split variable. And the training data itself actually are also saved there, but that doesn't matter too much. So that's the recipe command itself. And we can chain it together. We can have a pipe and manipulate these data. And all the commands that manipulate start with step underline. And then the following part is what this command actually does. So there is a command that is called step dummy. And conveniently, which is not an advantage here, I can just say, instead of listing them all, I can say all nominal data, all categorical data. I could also set waterfront here. And this could be it. But if I want to apply this already, I say prep. The consequence is that the pre-processed data for the training data set are already saved in here, and they can later be juiced out from this recipe. This juice only works if you have the prep at the end. Otherwise, you get an error message. So let's execute our recipe. No error message. And now I actually create my training data. And I told you already, in the recipe itself, we have the training data. We have the processed training data already. So I can just say juice, and I have to say which recipe I'm getting them from. And I put the data in the variable training data. I do the same for the test data. But remember, this prep included the training data in here, because this is the only data the recipe sees right now. So what I have to do now, I have to apply the recipe, and apply is called the bake, to a new data set. The complete command is actually this one, new data equals testing. Testing means take from the split, just take the testing data. I execute that, and I have my test data. And you can see my test data have 3,239 records, and my training data have 18,000 records. And if you add these two numbers, obviously you get the number of the original data set. Let's look if the change worked well. If actually our waterfront dummy was, our waterfront variable was changed into a dummy variable, and the answer is yes, waterfront is still here. Underline yes means that a yes is coded as a 1. That's very convenient. You can change that if you want, but I wouldn't do that. And conveniently, the original waterfront variable is deleted. It doesn't plug up our variables here anymore. So far, this repeats things, which also repeats things is now we want to run a regression, a multi-regression. We did that before with the LM command, but we do it here now inside a tidymodel environment. So we need two things. We need the command itself. This is linear regression. I can tell you I always would forget it. I would always go in the help file or in the internet, and then I find it. So you need the command itself. It's called linear regression. And inside that command, there is a mode equals, and you have to say it's a regression. I mean, if you type in classification in here, you get into trouble. I tried that. But there are a lot of procedures, and we will cover them. You can use them, for example, random forest is one, neural network is one. You can use them for regression problems, and you can use them for classification problems. So you want to tell the model if you're doing a regression or if you do a classification. Then you use the pipe command and say, set engine, that's basically which package to use. Again, you would get that from the internet. In this case, we use our LM package. So the same package we used before, but we approach it with different commands. And then if you want to run the command, then we need the command fit. This one. This is very similar to what that was the LM command before. Because what it has a formula, and it tells where the data are coming from. So get this back here. Here's a formula, price. Use all the data, obviously except price, in the data frame, data train, to predict the price. So data train. Here's the price. And use all these data here, waterfront, year build, view, floors, square foot basement, square foot lots, square foot living, and so on, to estimate the price. We do that, and we're done. All the information we need is saved in this variable. If you look careful enough, you will find it. It's a pain. See, it has lists in it and data and all kinds of stuff. But when you just name it, you get actually nicely the results. If you want the results nicely in a data frame, you can use the tidy command. Tidy is a command similar than summarize. It tries to put smartly things in a data frame. And sometimes you get a command and said, this machine learning procedure does not support tidy, but this one does. So here are our coefficients. And finally, with the metrics, we did that without further comment. I can get the quality. Let's look at the test data. So the mean square error, and I take the root of it here, if I use the test data to calculate it, it is about 200,000. On the training data set, it's 218. So they are similar. So no major overlearning is happening here.